Hi, and welcome to Reedy's Geometry. This is section 1.8, and we're talking about basic geometrical lines and how they can relate to each other. And there are really only four possible ways straight lines can relate to each other. Number one, they can be oblique, that is, they would intersect but not at a perfect 90-degree angle, something other than a 90-degree angle. They would be called oblique. If lines are in the same plane, but they do not meet, they are parallel. That's number two, a second way that lines can relate to each other. Lines could meet at an exact 90-degree angle. They could intersect. And if they're in the same plane, they are called perpendicular then. Two lines that are not in the same plane and do not meet are not necessarily parallel. You can see in my picture here, I've kind of represented the plane with this little kind of, sort of a parallelogram. And there's this line over on the left side of it, and the one coming down, hitting it, and coming underneath it. With markers, it looks like this. One here and one back behind going like this. They never meet, but they're not parallel either. Those lines that are not in the same plane are called skew. So lines not in the same plane that do not meet, skew. Same plane, meet at a 90-degree angle, perpendicular. Same plane, never meet, parallel. Same plane, intersect at something other than a 90-degree angle, oblique. Now let's do some examples. This is section 1.8, and I'm just going to work three examples from the worksheet. I'm going to work number 5, number 8, and number 10. First, number 5, you're given this drawing, and then it's going to give you two segments and say, what is the relationship between those two? Well, as I look at the picture here, it looks like a cube in number 5. I have to assume it's three-dimensional, that it's not all flat in the same plane. I've actually drawn it that way, but I don't want it to look that way. So here's this figure, and they want me to tell what kind of relationship there is between segment EM and segment PT. So what I might do, either with another color or you can use a pencil or something, kind of trace over those. EM's this one back here, and PT is this one down here. And the question is, what sort of relationship would they have? Would they ever intersect each other? It sure looks like they're headed the same direction. I think they're going to be parallel, so that's what I'm going to write, parallel. Now number 8, not quite the same shape. This looks like, this is what we would actually call a triangular pyramid. It's a pyramid because it comes to a point on the top, but its bottom base is actually triangle BYV. They want to know what the relationship would be between TV and VY. Well, again, I think I want to trace those. Use a different color this time. TV, that's right there. That's that side. And VY would be this back side. Actually would be dotted because it's back behind. Would they intersect? Yeah, they intersect in the point V. Does it look like they would intersect in a right angle? Doesn't look like it to me. So if they intersect but not at a right angle, that's oblique. So my answer for number 8, oblique. Make sure I spell that right, Q-U-E. And now number 10 gives me this box-looking thing here. And I think they intended to be a cube. I certainly did. I didn't draw it very well. But they want to know the relationship between MP, segment MP, and segment QT. All right, so let's trace over those. MP is here, sort of the left back corner of the box, running across and not up and down. QT runs up and down, and it's the right corner. If you extended those out into lines, would they ever intersect? the back of the box running back here someplace, and the front of the box going up and down. If this were a 3D, three-dimensional object, they would never cross. But they're also not parallel. So what do we call that? Well, they're not in the same plane and do not cross. That's skew. So I'm going to put skew. Nope, wrong color. Let's use black. Skew. All right, segment relationships in geometry.